The quantum numbers are integral numbers which tells about complete information about electrons moving around the nucleus of an atom. The quantum numbers, if you learn about the quantum numbers, you'll understand about the structure of an atom. Particularly, you'll be knowing much details about the electrons. What we understand about the electrons, the position and energy state of the electrons, and how the electrons are moving around the nucleus, in what direction the electrons are moving, and what is the shape of the orbitals, all will be understood by using the quantum numbers. So let us start discussion of the quantum numbers in detail. So this is the topic of the quantum numbers, 11th chemistry. So structure of this topic is taken from structure of an atom. Okay, and how many quantum numbers are present? There are four quantum numbers, four quantum numbers are classified. So out of four quantum numbers, three quantum numbers obtained after solving this Schrodinger wave equation. Schrodinger wave equation. And the fourth quantum number is a spin quantum number obtained later, which is independent quantum numbers, we say. So what are these four quantum numbers? One is principal quantum numbers. Number two, azimuthal quantum numbers, we say. The third one is magnetic quantum numbers. The fourth one is independent quantum number is spin quantum numbers, we write. So, and all these quantum numbers talk about electron, and all these quantum numbers tells about, all the quantum numbers will tell about electron. And so what they tell about electron means the complete detail and description of electrons around the nucleus, their position and energy state and orbitals and their orientation. So that means here all the four quantum numbers tell about the position of electron, energy state of the electron, and shapes of the orbitals and orientation of orbitals. These quantum numbers so talks about. That means all the quantum numbers talks about quantized energy states. Quantized energy states, we say. And let us discuss one by one. The first quantum number, principal quantum numbers. It is designated by principal quantum number designated by n. And these numbers start from 1, 2, 3, 4, and so on. The principal quantum numbers begin with 1, 2, 3, 4, so on, principal quantum numbers. And So it was introduced by the scientist Niels Bohr. Niels Bohr scientist. Niels Bohr introduced. So is the principal quantum numbers we say. And as the numbers increases, as this number integral number increases, 1, 2, 3, 4, the size and energy of the orbit increases. So what is the significance of this principal quantum number? The principal quantum number so determine the size and energy of the orbit as a number. For example, so if you take and one atom around the nucleus, there is n is equal to 1 first orbit, there is n is equal to 2 second, and n is equal to 3 third orbit. So this means as the quantum number increases, size of the orbit increases, and their radius also increases. Radius also increases, we say, and so these principal quantum number uh, indicate energy state. So there is a first energy level, second energy level, third energy level. As you know that in each orbit, energy is a constant, energy is a fixed. Hence, these energy levels are called stationary orbits or stationary shells we call. Stationary shells we say. And so these stationary shells main energy levels E1, E2, E3. So E3 has more energy than E2. E2 has more energy than E1, we say. And if you want to find out, if you want to find the energy of nth orbit, we have the formula minus RH 1 upon R square, where n is equal to 1. So, and the Rydberg constant, the energy of nth orbit, means first orbit if you take, so minus 2.18 into 10 to the power of minus 18 joules into 1 upon n1 square. So we get the energy 2.18 into 10 to the power of minus 18 joules is the energy present in the first orbit. Similarly, you can find out n is equal to energy present in the second orbit by using this formula. We can find out. So energy can be calculated, and even the radius of nth orbit. So a naught into a n square formula, where a naught is a constant 52.9 picometers. So, and if you n is equal to 1, then we get so 52.9 picometers into 1 square. So we'll get almost all. The minimum radius of the first orbit is 52.9 picometers. We get. So means the principal quantum numbers tells about radius. Principal quantum number tells about radius of the orbit, energy state of the orbit, and size of the orbit it talks about. Apart from this, radius, energy, size, and this principal quantum numbers tells about how many number of electrons can be accommodated in each shell. So these shells are indicated with the K, L, M, and N, so on. And each shell, if you use the formula 2n square formula, where n is equal to 1, the number of electrons are 2. And so that means n is equal to 1, number of electrons 2 accommodated, and n is equal to So in this 8 electrons and in this 18 electrons, and in the fourth orbit, the number of electrons accommodated 32. So based on the 2n square formula, we can fill the electrons in each orbit. So that means if we know the principal quantum number, then we know the number of electrons can be accommodated in each orbit by using the formula 2n square formula, which is called, this is said to be Borsbury rule. So this is about the principal quantum number, the first quantum number which was introduced by the Niels Bohr scientist. The next quantum number is about Azimuthal quantum number. The next quantum number is about Azimuthal quantum numbers. Azimuthal quantum number, we say this azimuthal quantum number was introduced by Sommerfeld scientist, and it is designated, or it is designated with the symbol L. So where this azimuthal quantum number L values start from 0, 1, 2, 3, and so on. Azimuthal quantum number values start from 0, 1, 2, 3, and so on. This azimuthal quantum number, otherwise called angular orbital quantum number, or it is said to be subsidiary quantum number also is right. Subsidiary quantum number, angular orbital quantum number also we write for this azimuthal quantum number, and it was introduced by the scientist Sommerfeld scientist, and it is designated with the L, and it tells about shape of the orbital, and it tells about number 2. So division of the main shell into subshells. So subshells, it talks about, so there are how many subshells are present in the orbits means. So these subshells are S, P, D, and F subshells. We say the meaning of S is sharp, P mean for principal, and D mean for diffused, and F for fundamental. So these are the names taken from the spectrum of atoms. Spectrum of the atoms, these names have been taken. So what does an azimuthal quantum number? Azimuthal quantum numbers tells about shape of the orbital and subshells. So idea of this azimuthal quantum number. So let us move further. So the azimuthal quantum number. So the shapes of orbitals. So what is the shape of the orbital? So as per the Niels Bohr, as per the principal quantum number, so the shape of orbital is circular. Does the electron exactly maintain circular motion? Does the electron maintain the circular motion? Is it possible all the time? So here it is a quite difficult. For example, as per the Niels Bohr atomic model, so electron revolve around the nucleus in circular manner. In circular manner, we say. So what does it mean circular? Circular. So electron, if we want, if we make the electron in the circular motion, or the electron is said to be in the circular motion when AB axis is equal to CD axis. That means an electron sweep out the radius around the nucleus equal in all direction. In all direction. Then only electron will be in the circular motion. Circular motion we say. But do electrons maintain the circular motion all the time? All the time means not possible. So where Heisenberg got the contradiction with this circular motion? As per the Sommerfeld scientists, what the Sommerfeld was suggesting, so electron not only moving in the circular motion, there is a possibility of so elliptical motion of the electron also possible. That means so that orbit will get ellipticity. The electron move around the nucleus ellipticity where the CD is not equal to AB. When CD axis decreases, then AB increases, then the electron will be, so electron will move elliptical shape where AB and CD decreases, AB increases. This is what we say ellipticity. An electron can get ellipticity. So how many elliptical orbits are possible in each shell? So how many possibilities are how many possibilities we can get for this ellipticity means that depends upon principal quantum number where so L values equal to n minus 1. If you know n is equal to 1, 1 minus 1, you'll get 0. 0 doesn't mean that nothing. 0 means here. So one subshell and so one subpath can be possible in n is equal to 1. And if you take n is equal to stationary orbit 2, L values start from how much? N minus 1, 2 minus 1, how much will get? So 1. So and the L value start from 0, 1 we say. 2 subshells are possible. If n is equal to 3 and L value start from 0, 1 and 2, so 3 subshells are possible. So these subshells are called subpaths and where the 0 indicate S subshell, 1 indicate P subshell and 2 indicate D subshell we say. That means if the principal quantum number is equal to 3 and 3 subshells are possible, that means the principal quantum number the principal quantum numbers, so number of principal quantum number of subshells is equal to what we call so principal quantum numbers also we write. That means so Azimuthal quantum numbers L is equal to so 0, means SR S subshell, 1 means P subshell, and 2 means D subshell, and 3 means F subshell. That means the main shell is divided into subshells S, P, D, and F, where S orbital accommodate the number of electrons 2, P orbital the maximum number of electrons accommodated 6, D orbital the maximum number of electrons accommodated 10, F orbital the maximum number of electrons accommodated 14. So finally, what I want to say from this is that azimuthal quantum number indicate or azimuthal quantum number signify shape of the orbital and shape of the orbital and subshells of orbits or stationary orbits it talks about. Subshells idea, that means main shells further divide into subshells, and these subshells are called SPDF orbitals, we say. Okay, so this is about azimuthal quantum number. That means energy of an electron quantized